Hello, Mr. Geiselhart here, and we're going to take a look at number 5 on the review for chapter 6-7. I need to find the area and perimeter of this quadrilateral. To find the area, the first thing I'm going to do is draw a rectangle that goes around the entire quadrilateral. Once that's done, you can see that there are triangles that are created between the quadrilateral and the rectangle that I just drew. I'm going to number them 1, 2, 3, and 4. So the idea behind this is I'm going to take the area of the rectangle and then subtract the area of these triangles, and whatever I'm left with, that's going to give me the area of the quadrilateral. So what we need to do is find the length and width of each triangle. So this would be 3 and 1, 2, 3, 4, 5. This one is 1, 2, 3, 4, 5, and 1. 1, 2, 3, 4, 5, 6, 7, and 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there we have all the dimensions of those triangles. Remember, the area of a triangle is base times height divided by 2. So for region number 1, we would have 5 times 9 divided by 2, which is 45 divided by 2, which is 22.5. For region number 2, 5 times 3 divided by 2, 15 divided by 2, which is 7.5. For region number 3, 5 times 1 divided by 2, which is 2.5. For region 4, we have 7 times 1 divided by 2, which is 3.5. Then we want to find the area of the rectangle. Well, the top of the rectangle is 8, the side is 10, so that'll be 8 times 10, which is equal to 80. So now we need to add up the area of all of those triangles and subtract that from 80. And when we add those together, we're going to end up with 36. So when I subtract, that will be 44 units. Now in this case, those were all triangles, but it might happen where you have a rectangle in there as well that you're going to have to figure out. So you can divide this up into things other than just triangles. So for example, if you had to, you could make maybe a rectangle that looks like that, and then have a triangle here and a triangle here. So it's not always going to be all triangles. You might have to make a rectangle in there. Now, to find the perimeter, we just have to use the Pythagorean theorem, in this case 4 separate times, to find the lengths of the hypotenuse of the triangles which make up the sides of the quadrilateral. So remember that the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So if we start with number 1, we will have 5 squared plus 9 squared is equal to, so that equals 106. So when I do the square root of both sides, I'm just going to leave that as the square root of 106. Next, let's look at region number 2. So that's 5 squared plus 3 squared, 34. And again, I want to take the square root of that, so I get c is equal to the square root of 34. Let's take a look at region 3. And in region 3, we have 5 squared plus 1 squared equal to c squared. So that's 26 equal to c squared. Do the square root, so c is equal to square root of 26. And then the last one, region number 4, we have 7 squared plus 1 squared is equal to c squared. So that's 50 is equal to c squared. Do the square root, and get c is equal to square root of 50. So now all we have to do is add together those sides. And I want to leave them as the square roots. I don't want to round to the very end. So you have the square root of 106 plus the square root of 34 plus the square root of 26 plus the square root of 50. And when you do that, you end up with 28.2966. We want to round to 2 decimal places, which means this 9 has to round up to a 10, which means that rounds to a 3. So we end up with 28.3.